The Corps of Engineers has a mission to maintain a 9-foot deep navigation channel on the Middle Mississippi River during times of low water. This mission is accomplished through the use of river engineering structures and dredging. Dredging involves hydraulically excavating the riverbed to effectively clear out sediment in shallow areas of the channel. Dredging is very effective, but the excavation in the channel is only temporary and must be repeated over and over again. Dredging is thus costly and can have a negative impact on wildlife habitat. The Vancill Towhead reach of the Mississippi River, which is between river miles 68 and 66, is a location where repetitive dredging has been required year after year to keep the channel open. The dredging has cost the taxpayer millions of dollars. This 2010 hydrographic survey shows how the sandbar off the left descending bank adjacent to Vancill Towhead encroaches out into the navigation channel, thus reducing navigation widths and depths. This 2011 pre-dredge survey shows the extent at which the navigation channel can become increasingly shallow without the use of maintenance dredging. If left undredged, this area of the channel would become even more shallow, eventually completely choking the channel off while no longer supporting navigation. The stoppage of navigation for just a single day has a huge economic impact to the nation. To solve this complicated problem, a micro-scaled physical sediment transport model, or hydraulic sediment response model, HSR model, was used to develop and test different river engineering alternatives. The use of the HSR model allows engineers to develop design solutions to reduce or eliminate the need for dredging and increase environmental diversity within the reach. You are looking at a close-up of the recorded video of the Vancill Towhead HSR model. The three-dimensional movement of water and sediment through the reach can easily be observed. The resultant model survey of this condition is now superimposed over the moving bed. This static survey captures the ability of the model to replicate or reproduce the actual observed sediment response of the Mississippi River. HSR models have the ability to accurately reproduce the trends of the river on a micro-small scale by using automated control systems' 3D laser technology. The ability to study the problem using a small-scale physical model allows engineers, as well as our navigation and environmental partners, to analyze flow and sediment changes together as a team in real time. From observing the model, you can see how inadequate navigation depths develop in the navigation channel without the use of periodic dredging. Once the sediment response from the river is replicated, river engineers can start using the model to develop, analyze, and compare many different design alternatives. These design alternatives can represent many different types of river training structures. The alternatives are developed and tested to find the most efficient and cost-effective solution to achieve all of the project goals. The recommended alternative in this model study uses a combination of weirs, revetment, dike repairs, dike modifications, and a new river engineering structure called the S-dike, or diverter dike. The structures viewed in the model generate the same sediment response as that of much larger structures observed in the Mississippi River. We will now examine the sediment response generated for the chosen alternative. The video speed is accelerated so you can see the response quicker. First, weirs are put in the model to effectively align the channel approaching the problem reach. Repairs to dike 67.8L restore the structure to its original elevation and length. Existing dikes 67.3L and 67.1L are shortened, and new revetment is placed along the left ascending bank line to reduce erosion. A diverter dike is placed in the model. The innovative shape of the diverter dike splits the approaching flow and sediment, deepening the main channel and creating a new side channel. A second and third diverter dike maintain the flow split. A new shallow water habitat bar is developed downstream of each dike. The diverted flow into the newly created side channel forms a long, deep scour hole along dikes 67.3L and 67.1L. The superimposed recommended alternative model survey shows that after all measures are implemented, adequate depths for navigation and an abundance of environmental diversity exist. These new environmental features, including the shallow water sandbar habitat and deeper water off-channel habitat, provide foraging and overwintering for fish. Costly dredging has been eliminated and barges can now navigate with no stoppages or delays.